Now this video is a continuation of the earlier video on database questions. And what we're going to do is that we're going to apply the approach and the concepts that we have learned in the earlier video into another database question. The database question that we're going to look at in this video is the 2019 database question. And as always, when we approach a database question, the first thing to do is do a quick scan of the passage to have a rough idea of what each paragraph is talking about, and we identify some of the key phrases and key ideas in each paragraph. Now at this point in time, it's perfectly okay to not have a very clear understanding of what each paragraph is talking about. We only need to know a general idea, and later on when we move on to the questions, if the question pertains to that particular paragraph, then you go back to the paragraph and try to make sense of the sentences in the paragraph. Okay, so if we look at the first paragraph, it seems to be talking about some introduction about bleachers. There are no or not many important concepts in there. It's just an introduction to bleachers. The second paragraph, however, if you take a look at it, there are some very key phrases and concepts that are being communicated. The first one is that the main compound in bleach is sodium hypochlorite. It is also known as sodium chlorate 1, and the formula is NaOCl. Alright, so this paragraph is talking about the all-important compound, sodium hypochlorite, also known as sodium chlorate 1. And the next line is also pretty important, okay, where it talks about the Roman numeral in the name. Now, the Roman numeral that we encounter in our syllabus is usually used for transition elements and not main group elements. Over here, the Roman numeral refers to chlorine, okay, which is not a transition element. However, they go on to tell you that the Roman numeral tells you the oxidation state of chlorine in the compound. So when you see a Roman numeral of 1, it means that it has an oxidation state of +1. Okay, so chlorine has an oxidation state of +1 in the compound. Okay, next paragraph, you see an equation over there. What does the equation represent? It represents the reaction of sodium chlorate with ammonia. Okay, and there's a very important concept or pattern that we will see later, which they tell you how the reaction takes place. Okay, it takes place by substituting a hydrogen atom, okay, on ammonia with a chlorine from your sodium hypochlorite. So statements like this, they tell you how a reaction occurs, or the pattern in which a particular type of reaction happens. The next part goes on to tell you that the product of the initial reaction can undergo further reactions. And since we are looking at the same type of compound, we would expect the type of reaction to be the same, meaning the pattern in which the compound undergoes reaction would be the same. Okay, and then they go on to tell you that the final product is nitrogen trichloride, and that nitrogen trichloride or compounds with nitrogen and chlorine are irritating and toxic to people. Okay, now the next paragraph tells you that sodium hypochlorite is not the only compound that can be used to make bleachers. Alright, so over here they tell you that in sodium hypochlorite, actually the main ingredient or the main species that is responsible for its ability to act as a bleach is your hypochlorite ion. Okay, they go on to tell you that it's known as an oxy-N ion, and also the sentence tells you what exactly does an oxy-N ion mean. It means that you have a covalent bond between oxygen and chlorine atoms. Okay, Over here, you are given a structure of chlorate oxy anion or your hypochlorite ion. And at this point, it's very important for you to remember that each line in a structure represents a covalent bond. Okay, so essentially it represents a shared pair of electrons. Okay, the next part tells you about calcium hypochlorite. So this is another type besides sodium hypochlorite. Calcium hypochlorite can also be used as an ingredient in bleach. Okay, and then they tell you two main advantages. Number one, it is stable. Number two, it has a higher percentage by mass of chlorate ions. So with a smaller amount or smaller mass of calcium hypochlorite, you can get more of the hypochlorite ions compared to sodium hypochlorite. The next paragraph talks about hydrogen peroxide, okay, which is another type of compound that can be used in bleaches. Right? Over here, they tell you that it produces water. When it acts as a bleach, it produces water. Water is the product. And then they go on to show you the structure of hydrogen peroxide. Once again, even though this is not tested in this particular question, but we could have easily asked you to draw the dot and cross diagram for hydrogen peroxide, and it is a rather simple question if you can just refer to the structure of hydrogen peroxide that's given. Okay, now let's look at the questions and try to think of which paragraph must we refer to in order to get the answer to the question. So firstly, suggest reasons why chlorate 1 ion, which is also your hypochlorite ion, is referred to as an oxy-N ion. So earlier there was a paragraph that talks about oxy-N ion, where there is a covalent bond between chlorine and oxygen. But over here, they simply want you to dissect the name oxy and N ion. Alright, chlorate 1 ion has the formula ClO-. So why would it be called an oxy ion? It's because it contains oxygen. Okay, and secondly, N ion. N ion in chemistry, it means negatively charged ion. So the second reason why it's called an oxy-N ion is because the ion has a negative charge. Okay, so these are the two things. Why is it called an oxy-N ion? Number one, it contains oxygen. And number two, the ion or the particle has a negative charge. Next, write an equation for the two reactions which leads to the formation of nitrogen trichloride from chloroamine. Okay, so this question is talking about the reaction of chloroamine or the reaction of your sodium hypochlorite with ammonia. So was there a paragraph that talks about the reaction? Answer is yes. Okay, so over here, if you can recall, there was an equation given. Okay, there was an equation given where ammonia reacts with sodium hypochlorite, and earlier I also mentioned that there is a pattern that's described in the passage. Okay, so in the subsequent paragraph, they also went on to tell you that the chloroamine that is formed, this is chloroamine, okay, can then react further with sodium chlorate. Right, so let's write down the formula of the two compounds, the two reactants first. Chloroamine plus sodium chlorate 1. Okay, so what can possibly happen, or how would the reaction take place? Once again, it is the same type of compounds undergoing reaction, so we would expect the pattern of the reaction to be the same, meaning this is the all important line: substitute a hydrogen atom on your ammonia or ammonia-like compounds with chlorine from your sodium hypochlorite. Okay, so you can see that in chloroamine there are still 2 hydrogens remaining. Okay, so we can go on to substitute with another chlorine atom. So what would we get is that we will get NHCl2, okay, plus NaOH, and now your NHCl2 can undergo another reaction with sodium chlorate 1 to form NCl3 plus NaOH. Okay, the clue for this reaction is also given when they tell you that the final product is nitrogen trichloride. Okay, nitrogen trichloride, as suggested from the name, it contains nitrogen and 3 chlorine atoms. Nitrogen trichloride. In the next part, the question requires you to find the oxidation states of nitrogen in each compound in the equations that we have just written, and show that sodium chlorate 1 acts as an oxidizing agent. So this is your sodium chlorate 1. If sodium chlorate 1 acts as an oxidizing agent, it can only mean one thing: that your nitrogen has been oxidized in the reaction. Okay, so essentially we need to prove that the oxidation state of nitrogen increases in both of these reactions. So firstly, we need to find the oxidation state of nitrogen in a few compounds. The first of which would be your chloroamine, NH2Cl. Okay, so since we want to find the oxidation state of nitrogen, we let it be X. What is the oxidation state of hydrogen? If you can recall, hydrogen has a fixed oxidation state in compounds, and the fixed oxidation state is +1. How about chlorine? Now, even though chlorine doesn't have a fixed oxidation state, in a case like this, all right, we can assume it to have a charge or to have an oxidation state of -1, right? Why is because halogens tend to form halide ions. Okay, it tends to acquire a charge of -1. Okay, and another clue given in the question is that should chlorine have an oxidation state that's not -1, it will be reflected in the name as the Roman numeral. Okay, so do you all recall that in the earlier part they told you that sodium chlorate 1, the 1 represents the oxidation state of chlorine. So that is a very little hint to tell you that halogens, they tend to have an oxidation state of -1. That means chlorine tends to form chloride. Okay, otherwise, if it doesn't have an oxidation state of -1, the oxidation state will be reflected in the name itself. Okay, so in this case, we can assume chlorine or other halogens to have an oxidation state of -1. Once we have established the oxidation state of chlorine, we can go on to use the rule where the sum of oxidation states of all atoms in a compound is equal to 0. So X plus 2 times 1 plus -1 equals to 0. So that would give us an oxidation state of, let me use a different color to represent it, -1 in chloroamine. Okay, how about for the product NHCl2? Once again, we let the oxidation state of nitrogen be X. Hydrogen is +1, chlorine again is -1. So X plus 1 plus 2 times minus 1 equals to 0. So in this case, your nitrogen would have an oxidation state of plus 1. Okay, and then the last nitrogen containing compound that we need to figure out the oxidation state for would be your nitrogen trichloride. In this case, chlorine, it has an oxidation state of minus 1. So x plus 3 times minus 1 equals to 0, x equals to plus 3. Okay. So how then do we phrase the answer? I'm not going to write this out, but in the first reaction, or in the first equation, to simplify things, you can label the equations, equation 1 and equation 2. In equation 1, nitrogen in NH2Cl has been oxidized, okay, or NH2Cl has been oxidized as the oxidation state of nitrogen increases from minus 1 to plus 1. Okay, in equation 2, NHCl2 has been oxidized because the oxidation state of nitrogen increased from plus 1 to plus 3. So since NH2Cl and NHCl2 has been oxidized in the two equations, this shows that sodium chlorate 1 is an oxidizing agent. Okay, the reason why I'm not going to write down is because you can just refer to the answer in your 10-year series. The next part, we are supposed to draw a dot and cross diagram to show the outer shell arrangements in chlorate oxyanion. Okay, meaning we are supposed to draw a dot and cross diagram for ClO minus. Now the drawing of dot and cross diagrams for polyatomic ion, right? If you haven't noticed, this is a polyatomic anion or polyatomic ion. Now the drawing of dot and cross diagrams for polyatomic ions are not in the O-level syllabus. However, it can still come out provided the structure of the anion is given to you. So if we look at the question, indeed they did give the structure of the anion, and the structure will provide a hint to you as to which atoms are sharing electrons with which atoms and how many electrons are shared. So all we need to do now is to convert the structure into a dot and cross diagram. Okay, so firstly, since the question talks about chlorate oxyanion, you're supposed to locate the part that talks about this oxyanion, and when you go to the relevant paragraph, you would locate this particular structure. So how then do we convert? So we have a chlorine atom. We have a chlorine atom that's sharing electrons with oxygen atom. And how many electrons are being shared? You can see that there's one line over here. It means that it shares only one electron. Okay, after sharing one electron, chlorine would have 6 electrons remaining, and oxygen would have 5 electrons remaining. Okay, so now if you look at the structure, if you look at the dot and cross diagram, you would notice that chlorine already has a fully filled valence shell, okay, stable octet electron arrangement. But if you look at oxygen, it doesn't. It only has 7 electrons. Okay, so how then can we have a stable octet electron arrangement for oxygen as well? That's where the minus charge comes in. What does a minus charge mean in chemistry? Is that the substance has gained an electron. Remember, electrons are negatively charged, so when you gain one electron, you will gain a negative charge. That means that your ClO would have gained an electron from somewhere. Okay, in this case, how do I represent it? I'll represent it as an unshaded dot. Okay, and then the whole thing will have a minus charge. Right? So the legend would look something like this. X would be the electron of chlorine, the shaded dot would be the electron of oxygen, and the unshaded dot would be the electron gain, possibly from a metal atom. Okay, example, sodium. Alright, so in sodium chlorate 1, the extra electron is actually donated by sodium. For part D, show by calculation that the percentage by mass, so this is a keyword over here, percentage by mass of chlorate in calcium chlorate 1 is greater than the percentage by mass of chlorate 1 ions in sodium chlorate. So which paragraph do we want to refer to would be the paragraph that talks about calcium chlorate 1. Okay, calcium chlorate 1. If you can recall, in the paragraph it talks about the two advantages of calcium chlorate, but to solve this question, you don't really have to refer to any information given in that passage, but rather you need to recall this, that in our syllabus we learn percentage by mass. And how do we calculate percentage by mass? In the topic of mole concept, we learn that to calculate percentage by mass we need three important information. One is the mass of part, two is the number of parts, and three would be the mass of the whole compound or the whole substance. Okay, so we are going to calculate the percentage by mass of chlorate ion. So the part that we are looking at now would be your ClO. Okay, this is the part. Okay, number of parts would depend on the formula. So later we need to come up with the formula of sodium chlorate 1 and calcium chlorate 1. Okay, and then the mass of whole would be the formula of the whole substance of the sodium and calcium chlorate. Okay, so how do we get the formula of sodium chlorate 1? This one is given in the question, so NaClO. For calcium chlorate 1, it requires you to recall something about the writing formula for ionic compounds. So what is the formula for calcium chlorate 1? We have seen earlier they have given you the formula of the chlorate ion, so ClO minus. The formula of calcium ion, calcium is in group 2, so it will form an ion of 2 plus. Okay, in order to get the formula, since the ions do not cancel out to 0, the charges on the ions do not cancel out to 0, so we need to do a cross multiplication in order to get the formula of calcium chlorate. So it's ClO2. Alright. So with the formula of the two compounds, we now know the number of parts. For sodium chlorate, the mass of the part, okay, would be, that means the mass of ClO would be 35.5 plus 16. Okay, number of parts would be equals to 1. Okay, because there's only one ClO in the formula. The mass of the whole, that means the whole thing, will be 23 plus 35.5 plus 16. Now for calcium chlorate, the mass of part is the same because we are looking at the same part, which is ClO, but the number of parts would be different. If you look at the formula of calcium chlorate 1, there are 2 ClO units in there. Okay, so 2 of them, and the mass of the whole, in this case, we need to calculate the molar mass of the entire formula unit. Alright, once we have the 3 pieces of information, Percentage by mass is very simply the mass of part times the number of part divided by the mass of the whole. Okay, in this case, if you do everything correctly, you will get a percentage of 69.1. Okay, similarly, for calcium chlorate, if you apply the same formula, you will get a percentage of 72.0%. Okay, so the key challenge with this question, or it lies in first recalling how to get percentage by mass, and secondly to derive the formula of calcium chlorate 1. Now the next question requires you to deduce the formula for calcium peroxide. So the keyword in this question is peroxide. So which part of the passage talks about peroxide? It will be the part on hydrogen peroxide. Okay, recall that you are given the structure of hydrogen peroxide, and they went on to tell you that the oxidation state of oxygen in hydrogen peroxide is -1. Okay, now this is consistent with the redox rule that the sum of oxidation states of all the atoms must be equals to 0. Okay, the other thing is to recall the definition, or one of the definition of oxidation states. It is that the oxidation state reflects the charge on the atom if it were to behave like an ion. Alright, so peroxide ion would represent your O2. And if you take a look at the oxidation state, the total oxidation state, each oxygen would have an oxidation state of -1, meaning that O2 would have, if it existed as an ion, it would have a total charge of 2-. Alright, once you have established the charge on the peroxide ion, the rest is pretty routine. Calcium is in group 2, Ca2+. The anion is O2 2-, so you can see that the charges do cancel out, so there's no need for you to do any cross multiplication, and the final formula is just CaO2. In the last part of the question, they ask you a reason why hypochlorite bleaches cause people to have adverse reactions, but hydrogen peroxide bleaches are less likely to do so. Okay, so adverse reactions, if you try to locate a part on the passage that talks about adverse reaction or being bad for humans, there's actually a part that talks about compounds of nitrogen with chlorine irritating and toxic to people. Alright, so the question actually requires you to make reference to this part and talk about hypochlorite bleaches. It will produce NCl3, okay, which is irritating and toxic to people because it contains nitrogen and chlorine. Okay, but that only answers half the question, because you have to then go on to tell us why is it that hydrogen peroxide bleaches, they are less likely to do so. So you have to locate on the part. Since hypochlorite bleaches produces nitrogen trichloride, what would hydrogen peroxide bleaches produce? And in the part of the passage, it tells you that it produces water. Alright, so you have to mention this part as well, that hydrogen peroxide bleaches produces water as the product, so it is harmless to humans. Now lastly, if there are any other database questions where you wish to have a thorough examination of how we can apply the approach or strategy into that question, please leave a comment and I will consider doing it for the very next video.